Hello, everybody. I'm Captain MAMGAIN. When we started off, we talked about navigation was trying to get the ship from one place to another by determining its position, course, and distance. Now we already talked about position. Position is in terms of latitude, longitudes. Wherever they intersect, that is the position of a particular place. And that's only one possible one condition. It's unique by itself. If you look at it here, I am showing you two, say, people standing close to each other. The position are not the same. Whatever you say, whatever fraction, they are different. They will be the same if one man was standing on another one. Then your position is the same. So position is unique and defined by its latitude and longitude. It could change by a fraction of a second or whatever it is. Latitudes and longitudes are all spherical angles because they are being formed by circles, intersection of circles. And all of them, what we have talked about, are spherical angular measurements. They are not linear measurements. And angles would be measured in degrees, minutes, and seconds. We know 1 degree is 60 minutes and 1 minute is 60 seconds. So you can do the conversion accordingly. In navigation, so far, whatever we have talked about, we have talked is like we have been in the center of the earth. When we said latitude is arc or angle at the center of the earth. Longitude, again, arc or angle at the center of the earth. But we can't be at the center of the earth. So all the measurements should be done along the circumference of the sphere. So we will measure everything on meridian and the equator. Now the length of this arc, what an angle would subtend, would vary with depending upon what is the radius of the sphere. Now, if suppose I had this, what I'm trying to show you is the Earth right from top of the North Pole, and this is the greatest possible circle, which is the equator, and these are small circles which are your parallel of latitudes. Now, if there was a arc which I was making of 90 degrees or an angle at the center of 90 degrees. Now, all these three circles, what I'm showing you here, the angle subtended in the center is 90, but the arc is varying depending upon the radius from the center. Of course, we are measuring everything when we talk about latitude or longitude. We are talking in terms of meridians or equator, which are great circles. So there is no ambiguity about what is the size of the arc. So as far as we are concerned, there is no ambiguity. But when we talk about nautical miles, that is where we'll come to this. And all these, as I said, their angular measurement would be measured in degrees, minutes, and seconds, not in centimeters. Now to get the things to be changed into linear distances. This is a very important topic for me as far as I am concerned because we should know that when we can change what into linear distances. So here we have finished off with position. Now today let's talk about distances. Now, as I said, we should know what is the distance between 2 points when we are sailing. And we know that there are quite a lot of units what are used for measuring distances. We talk about centimeters, inches, feet. But out at sea, we talk about nautical miles and we'll stick to nautical miles. Now, this is just an explanation about the angle what an arc will angle makes. So these are three circles what I'm showing you here with varying curvatures. Now, this will have the maximum curvature because, and this is having largest, the least curvature here. And we know that the earth is also flat. So the angle what 1 degree will make at different places will vary. Now, as I showed you here, with this one having the least curvature and this having the maximum curvature here, the arc what is being made at the maximum curvature is least, and what is being made at with the least curvature is the maximum. And when we talked about Earth, Earth is basically flattened at the top. When it is flattened, that means more or less straight. That means the curvature is the least possible. Whereas the great circle is a perfect circle, so that will have the maximum curvature. So looking at this, the angle of 1 minute would be making a smaller arc at equator and making a bigger angle at the poles. So you have maximum curvature here, minimum curvature here and maximum curvature at the equator. So the angle of 1 minute is making a smaller arc here and maximum arc at the poles. Now, how do we define nautical miles? That is the linear measurement. Nautical miles is the arc of the meridian. Arc of the meridian. Meridian is the great circle or semi-great circle. So, which is making an angle of 1 minute at the center of curvature of that particular place. When we talked about curvature, we said at poles it is more or less flattened up, so that way the curvature will be the least. So there, the arc, what an angle of 1 minute will make, will be the maximum, and that's about 1862 meters. Whereas at equator, the circle is perfect circle. The curvature is going to be maximum. There the arc would be the least, which is 1842 meters. But for us, we should have a standard value for a mile, and we have taken the standard value as 1852 or 6080 feet. The nautical mile is the length of the nautical mile is 1852.3 or 6080 feet. And we know speed is kilometers per hour nautical. So here speed is in knots. Nautical miles per hour is your speed. Now, what do we measure along the meridian? We measure latitudes and delats. That is what is the definition of latitude and delat was. And we are measuring them north and south. Now, this is arc of the meridian, and nautical mile is also arc of the meridian. Latitude delat. So if I go by the definition of nautical mile, delat can be converted into distance. So if I know a delat between 2 points, I can call it as a distance also between 2 points. But if you see here, I have taken out point C. Now the delat between point A and point C is the same because delat is the arc of the meridian contained between these parallel. But then A to C is not the distance. So delat will not be the distance all the time. Delat would be the distance only if these 2 points are on the same meridian, that is north and south of each other. This is important. I'll keep on repeating this because we will require this when we start solving the problems on parallel sailing. So do not mind me repeating this on and off. Now, in charts, you take the latitude scale as the measurement of your distances. Now, as the definition is arc of the meridian. Meridian runs north and south, and your scale of your latitude is running north and south. So basically, when you're using that, you're measuring the length of the arc, and that is the reason that you're taking your latitude scale as your scale of measurement for distances. Now, at equator, if you have got 2 points, as I've shown you here, A and B, what do we measure along the equator? That is your longitudes or D long. Now, equator runs east and west, what we talked earlier also. So, at equator, if there are 2 points, if I go by the definition of nautical miles, which is arc of the meridian, meridian is a great circle, equator is a great circle. So, in this respect, I can consider this also to be taken as nautical miles. So, on equator, 2 points Now, if they are on the equator, that means they have to be east and west. And then this east and west distance or the longitude or the d long between the 2 points on the equator can be converted into distance. Now, d long all throughout, you can see as the thing is going up, it's the same. Longitude or d long between these two meridians is the same. But anywhere else, I will not consider that to be the east-west distance, because now east-west distance between any 2 points here would be along a parallel of latitude, and parallel latitude is small circle, so it will not fit in to my definition of nautical miles. So east and west distance here between 2 points on some other parallel latitudes, I cannot convert that longitude or d long into distance. And as you can see, that the distance between the two meridians as we approaching the poles reduces, and that distance, east and west distance between 2 points on a parallel of latitudes, is called departure. How do we find out? That will be the next topic when we start talking about sailing. Now at equator it is longitude or d long, depending upon either it is Greenwich meridian or two different meridians. So at equator, this I can convert into distance. Nowhere else. Nowhere else. Only here at equator, I can say the 2 points A and B on the equator, east and west, the distance between them is whatever is the d long or the longitude between them. Anywhere else on any other parallel of latitude, that would be wrong to call that as the east-west distance, because the east-west distance on any other parallel of latitude is called departure. And how do we find out? As I said, will be topic of discussion later. And that's why I've written down here, it's got the same d long, but that cannot be converted into distance because that is called departure. East-west distance is called departure here. Now, latitude is an arc of the meridian, and here you can see the latitude coming up here. And I've taken it as an arbitrary value of 50 degrees. Now, nautical mile is also arc of the meridian. Latitude is also arc of the meridian. Of course, latitude is an angular measurement, but here I can call it to be the linear distance also. I can convert this latitude from equator to point A. It is 50 degrees. I can call it as a distance also, linear distance, which would be 50 into 60, so many minutes, and that will be converted into nautical miles. So all the points here, when they are on the parallel of latitude A, are 3000 miles away from here. That's for this particular thing, only about the latitude part of it I'm talking about it. Now if we had 2 points A here, I'm showing you as 60 degrees north, B 60 degrees south, 30 degrees south. The D lat between them is 90. The D lat is what? Is the arc of the meridian. And you go by the definition of nautical mile. I can convert this D lat into distances only if these 2 points are on the same longitude or same meridian. So if there are 2 points which are exactly are on the same meridian, which is north and south of each other, the d lat between them is the distance also between them. So this is important for you to remember. Only if the 2 points are on the same meridian, that means the longitudes are the same, then the d lat is the distance between them, can be converted that into distance. Here I'm just trying to show you now 2 points A and B. Now they are both in different meridians, but of course, in this previous example, the d lat between them is 90. And d lat is angle at the center or arc of the meridian which is contained between them. And as you can see, that this arc which is moving here, the arc is the constant same between both of them. So the delat between these 2 points is 90 degrees, which in minutes is 5,400 miles. But that would not be the distance, because which meridian? A is on different meridian, B is on the different meridian. So I cannot uh, say that my delat is the distance here. Delat would be, the distance would be, I made this great circle here. And great circle, what this is measuring it along a great circle, arc of the meridian. I've just made a great. So this would be the distance between A and B, isn't it? This would be the distance. Arc of a great circle, which is passing through A and B. And we can always draw one great circle here. Imaginary circle here. It is not there in any of your books. This is all from out of my head. So just to get you think. So the delat here is not the distance. The distance has become A and B. So this is the distance between A and B, not the delat. Not the delat. So this is important for you to remember that delat, only if the 2 points are on the same meridian, can be taken as a distance. But if they are on two different meridians, then the distance is going to be different, and that will have to be calculated, which we'll be dealing once we start talking about sailing. As I said, which meridian I should have taken it. So I have drawn this as a meridian. And now I can get this meridian up here and measure it. And as you can see, that the distance is definitely greater than the delat. If you look at it as a plain triangle, this is the hypotenuse. So that will be bigger than either side. The same thing with longitude. Longitude is what? Is the angle which is being formed by the planes of two great circles at the center of the earth. And being great circles, then their plane has to pass through the center of the earth. So, and it is being measured at the equator. Now, this is the longitude, and I've just taken an arbitrary value of 50 degrees to the west. This is your Greenwich meridian. And the longitude between these two meridians will be the same throughout. Now, its arc of the meridian, I'm repeating it, equator is again a great circle. So here, again, by definition of the nautical mile, I can convert this into linear distance. And at equator, if there is some points here, I can say, yes, they are so many miles away from the equator. That's your east and west, because you're measuring it along the equator, and equator is running east and west. So at equator, I can always convert that into east and west distance, only east and west distance. The d long throughout is the same on any on between these two meridians. But the east and west distance, as you can see, this longitude going up, is the same. But the east and west distance is not the same. It is changing. It is reducing. I've taken two parallel of latitude, two parallel of latitudes and two meridians, and finding out the d long. D long is 100 degrees. D long between A and B, irrespective of where they are, is going to be the same, 100 degrees. If you see this, this is moving here. All throughout, the D long is 100 degrees. Now, D long, arc of the equator, we talked about it. And equator, as we said, is the great circle. So D long can be converted into linear distance east and west, because equator is running east and west. So the d long, I can convert it into distance and say, yes, A and B are 6,000 miles apart at equator. At equator, they are 600 miles apart. Now, 2 points which are on different parallel latitudes. Now, this east and west distance being measured now, east and west, even parallel latitudes on east and west. If it is going to be measured along this, that will not be the distance east and west. That distance here, east and west distance, is called the departure. And it will not be the same as the d long. Though the d long between these 2 points is also same, 100. But the east and west distance will not be what we have converted it here. And as you can see that the distance is reducing. So at equator, d long can be converted into distance. On other parallel of latitudes, d long will not be the distance between 2 points east and west. This word important, east and west. East and west distance between 2 points on the equator is the d long, is also the distance, and you can even call it departure, though it is wrong word, because departure is on up parallel of latitude, not on the equator. So I can convert my d long to linear distances here at equator, but on other things I will not call it as a distance between 2 points, east and west distance between 2 points. Now here I have just taken a third point here, C, which is on this meridian here. So the d long between B and A and B and C is same, 100 degrees. The east and west distance between B and A, here I converted it into distance. To find out the east and west distance between A and B, I'll have to find out the departure, which is going to be, as I said, a topic of discussion later. And the distance between them, B and C, would be an arc of a meridian which is passing through both of them. An arc of the meridian I've just drawn it as a great circle. So the distance between B and C will not be the d long. So this is important for you to remember what can be converted into distance, where it can be converted into distances as we proceed further for sailing. So just to conclude here, we are doing all our measurements along the great circles. Let it be longitudes, latitudes, and now even nautical miles. When we said meridians, meridians are part of great circle. So we are measuring latitudes and delat along the meridian. Now if there are 2 points A and B on the same meridian, A and B on the same meridian, or in other words, if I just said A and B are north or south of each other, that implies that the 2 points are on the same meridian. The delat can be taken as distance by the definition of nautical miles, which is arc of the meridian. But if there is point C on the same parallel as B, the delat is still the same, but the distance will not be the same as delat. Now the distance is going to be A to C. Similarly, for longitudes, we measure the longitudes or d long along the equator. These two meridians, if you see, the d long is same throughout, right from equator up to the poles. But at equator, and equator is running east and west. So 2 points on equator, if they are on the equator, then they will be east and west. Of course, if there are 2 points are there on a parallel of latitudes, also will be east and west, because latitudes also run east and west. At equator, as per the definition of nautical mile, which is arc of basically a great circle meridian, I can convert the d long at equator into distances. But here, these arc, east and west arc is short, small circle, so I will not be able to convert it into distance. So d long, as long as it is there given to you in a question on uh, equator, yes, can be converted, but not on any other latitude. On any other latitude, the east and west distance is called departure. So at equator, d long is equal to distance, can be converted into distance, or I can call it departure. So the word departure would not fit in here. Anywhere else, I cannot convert the d long into distance here. Here I have to find out what is the departure, east and west distance. This I am talking about only east and west distance. Thank you very much. I will meet you next with directions. Till then,